Everyone is lying to you. The truth is that you simply cannot die, and you can never truly reach an end. A life of misfortune sounds crazy, doesn't it? But in the face of quantum mechanics, death might just be a non-existent illusion. This is called quantum immortality. Once you understand this, you won't just feel a chill down your spine, you will even begin to doubt the reality of the entire world. Imagine this. When you pull the trigger of the gun in your hand, you do indeed fall in this world. But in another parallel universe that has branched off, the bullet just happened to jam. You survived completely unharmed. Your consciousness will always remain only in that universe where you are alive. It is an infinite loop. No matter if you face a car accident, a terminal illness, or an unexpected disaster, there is always a version of you in some universe that is alive. You think you have only lived for 20-something years, but in a certain dimension, you may have already lived for hundreds of millions of years. Watching your loved ones leave one by one, only you are trapped forever in a prison of time, unable to feed life and unable to find death. This is not science fiction. This is the many worlds interpretation proposed by Hugh Everett in 1957, which terrified the physics community at the time. I know what you might be thinking now. Isn't this just a wild, crazy idea? Why should I be unable to die? Don't be so quick to judge. To understand this logic, we must first peel back the illusions of this world. You think you are sitting firmly in your chair right now. You think the screen in front of you is solid, tangible matter. But under a physicist's microscope, these so-called realities simply do not exist. Magnify anything around us. For example, if you magnify a speck of dust on your hand by 1,000 times, what do you see? Bacteria, microscopic monsters with complex structures. Magnify it further, and you will see the cell nucleus, the blueprint of life. Magnify it another 10 times, and you see intertwined DNA strands. Up to this point, everything seems normal. But what if we continue to magnify to the extreme? You will see individual vibrating atoms, and the most bizarre thing happens. The interior of an atom is empty. 99.999% of it is empty space. If the nucleus were a marble, then the electrons orbiting it would be like a fly several kilometers away. Since it is all empty, why does it feel solid when I touch it? Why can't your hand pass through the table? That is actually the repulsive force between electrons, deceiving your sense of touch. Simply put, you have never truly touched anything. All you feel are forces, and the smallest units that make up this world, those electrons, photons, and quarks, they are not at all the well-behaved little balls you imagine. They are a bunch of absolute lunatics. This brings us to the experiment that haunted Einstein until his death, and made Feynman exclaim that no one understands it. The double-slit experiment. This experiment is regarded by many as a strong hint of the existence of parallel universes, and it was the first time humanity glimpsed a bug in God's source code. Simply put, scientists fire photons one by one through two narrow slits, hitting a screen behind them. According to common sense, if you throw stones through two doors, there should be two marks left on the wall, right? But a strange thing happens. A series of alternating light and dark stripes appear on the screen, just like water ripples. This shows that photons are not individual bullets, but rather a wave. It passes through the left slit and simultaneously through the right slit. It interferes with itself, creating an interference pattern. Now, while this is strange, it is still acceptable. After all, light is both a particle and a wave, but the real horror show begins the next second. Scientists, skeptical of this, placed a camera next to the slits, hoping to see exactly how this photon manages to pass through both slits at once. The moment the camera was turned on, the photon seemed to suddenly gain consciousness. It sensed that we were watching, and the stripes on the screen vanished instantly, replaced by two simple, well-behaved bands formed by particles. As long as you don't look at it, it exists in two places at once. But the moment you observe it, it immediately settles into a single, definite position. Think about how terrifying that is. It is like having a cat at home. When you leave the house, it is dancing, reading, and doing backflips, perhaps even being in the kitchen and the bedroom at the same time. But the moment you open the door, It is immediately lying in its bed, pretending to sleep. Our act of observation, actually, determines the state of matter. This means that in the microscopic world, there is no such thing as a definite reality, only an infinite superposition of possibilities. So, the question arises, if microscopic particles are indeterminate, why are we, who are made of these particles, so definite? To explain this massive contradiction, the famous Schrödinger's cat was born. Place a cat in a box, connected to a poison gas device. The device is controlled by a radioactive atom. This atom has a 50% chance of decaying. If no one observes it, the atom exists in a superposition of decayed and undecayed states. Following the chain reaction, the cat is also in a superposition of being both dead and alive. Note this. It is not that the cat might be dead, or might be alive, but that it is simultaneously in a superposition of both states. Until the moment you open the box, the universe is forced to make a choice. The cat is either dead, or it is alive. This drove physicists of that era absolutely mad. How could a cat be both dead and alive? While everyone was still struggling with the idea, that observation causes a collapse which seemed too absurd. In 1957, a graduate student at Princeton University named Hugh Everett stepped forward. He proposed a shocking, world-shattering idea. Who says the cat must be one or the other? Who says observation causes the wave function to collapse? Everett argued that when you open the box, the world does not collapse, it splits. At that moment, the universe divides in two like a cell. In universe A, you see a live cat, while in universe B, that version of you sees a dead cat. Both versions of you are real, each with their own memories, but you can never see each other. This is the many worlds interpretation. It means that there is no such thing as mere possibility. Everything that could possibly happen has already actually occurred. If you hesitated this morning between coffee or milk, you don't need to worry about it, because in one universe you drank coffee, and in another you drank milk. If you once struggled with the choice of staying in a big city or returning home to take a civil service exam, don't regret it. Another version of you is living that other life right now. This even applies to life or death moments. Remember the quantum immortality mentioned at the beginning? If you are crossing the street and a car rushes toward you, in the countless split universes, in some you are hit. But in one of the branches, the driver hits the brakes and your consciousness naturally continues in that surviving body. Does this sound like some cheap placebo? Yet for Everett, who proposed this theory, it was a lifelong tragedy. When he presented this paper, which was enough to shatter the foundations of physics to the quantum mechanics. Pioneer Niels Bohr, he was met with ruthless mockery and indifference. The scientific community of the time could not tolerate a mad universe that splits infinitely every second. Everett was disheartened. He left the field of physics entirely, switched to defense research, and became a heavy smoker and drinker, living in constant melancholy. At the age of 50, he suffered a sudden heart attack and died in his bed. If parallel universes are real, then in another universe, Everett might have become a revered Nobel laureate. But in our universe, at the time of his death, he was still a forgotten outsider to the academic world. The most heartbreaking part happened years later. Everett's daughter, Elizabeth, had long suffered from mental illness. After a serious suicide attempt, she left this world. In the suicide note found by the police, Elizabeth left behind a message that brought people to tears. She wrote that she had not died, but had simply gone to another parallel universe to find her father. This might be the rambling of a troubled mind, but it could also be the most poignant physics love letter in the world. If the many worlds interpretation is true, then she wasn't lying. In some branch of the universe, she truly opened the door and saw her father alive and loving her. But this is just a theory after all. Is there any hard evidence? We live in an age that demands proof. With the advancement of technology, scientists have begun searching the cosmos for traces left by other universes. Evidence may have already appeared, and it is shockingly large. If you have seen the cosmic microwave background map, the photograph that records the residual heat of the Big Bang, you will find that the temperature distribution of the entire universe is remarkably uniform. However, in the direction of the Eridanus constellation in the southern hemisphere, there is a huge, mysterious region. The temperature there is much lower than its surroundings, like a perfect blue void. Scientists call it the cold spot. According to our current cosmological models, this thing shouldn't exist at all. If it were formed naturally by the Big Bang, the probability of such a large cold spot appearing is lower than winning the lottery jackpot 10 times in a row. So, where did it come from? One of the most exciting explanations is that this might be a cosmic-scale traffic accident. Imagine, our universe is a giant soap bubble floating in a higher dimensional space, and next to us are countless other bubble universes. When our bubble collides and squeezes against a neighboring one, the energy exchange leaves an indelible bruise on the edge of our universe. This cold spot is that bruise, the tangible evidence of another parallel universe crashing into ours. And that is not the only strange thing. Ever since the James Webb Space Telescope, known as a time machine, was launched, the images it has sent back have left astronomers' jaws on the floor. It has seen things that shouldn't exist. Just a few 100 million years after the Big Bang, theoretically the universe was still a chaotic mess, with barely any stars formed. But the Webb telescope actually captured several fully mature, well-developed galaxies. These galaxies are massive, bright, and possess clear structures, much like a newborn infant that somehow has the face of a 40-year-old. This completely contradicts current theories of cosmic evolution, unless our universe is not experiencing its first birth, or perhaps this matter leaked in from another universe. Physicist Michio Kaku once used an analogy. It is like listening to a radio. You are currently tuned to 1019, and you assume it is the only signal, but in reality, your living room is filled with waves of every frequency, like 885 or 947. They pass through your body and through the walls. It is just that your radio cannot receive them. But occasionally, the signals cross over. Have you ever experienced a moment like this? You go to a place you have never been before, and suddenly, the scene feels incredibly familiar, to the point where you know exactly what the person next to you is about to say. This is déjà vu, often referred to as the hippocampus effect, or even larger-scale collective memory distortion, known as the Mandela Effect. Thousands of people swear that they remember the tip of Pikachu's tail being black, even though in reality it is entirely yellow. Is this a failure of our collective memory, or is it possible that our consciousness once, for a brief moment, accidentally brushed against the edge of an adjacent timeline? Perhaps in that universe, Pikachu's tail really is black, and when the orbits of two universes draw too close, our memories experience a tiny instance of quantum entanglement. Speaking of which, I know you might feel a sense of helplessness. If there are infinite parallel universes, if every choice corresponds to a new world, does our current effort still have any meaning? If a version of me who is incredibly wealthy already exists, then why am I struggling so much right now? Am I just that unlucky? Actually, we can look at it from another perspective. The parallel universe theory might be the gentlest remedy for a world full of regrets. We all have moments of regret. Regretting not studying a little harder for that exam. Regretting saying harsh words during an argument. Regretting not holding that person's hand at the final moment. But the many worlds interpretation tells you that those regrets have all been mended. In this universe you failed, but in that branch you succeeded. The person you couldn't save is sharing a drink with you in that other world. The dream you couldn't realize has already become reality in that world. Even that crazy quantum suicide experiment, if it were true, might be hinting to us that consciousness could truly be indestructible. We are like ghosts, jumping between infinite channels, forever searching for the universe that allows us to continue existing. Of course, all of this currently remains within the realm of theory and mathematical formulas. The universe is not only stranger than we imagine, it is stranger than we can even imagine. You, in front of the screen, just blinked your eyes. Congratulations. In that very instant, the universe split again. In one whirl, you swiped away from this video, but in this world, you listened until the very end. I am grateful that, In this specific branch of the universe, at this very moment, we have had this connection. Thanks for watching. If you enjoyed this journey through science, don't forget to like, subscribe, and share this video. See you in the next exploration with Quantara Atlas.